Hello everyone. Welcome to the exciting world of microprocessor and microcontroller, or as we love to call it, MPMC. I am Maheshkumar, faculty from Department of Electrical Electronics Engineering, Hindustan College of Engineering and Technology. This course offered to the both EEE and E&I students under the BE curriculum. Whether you are diving into the hardware design or the embedded system, this course will going to help you to give a strong foundation in a basic of microprocessor and microcontroller. Before we jumping into the registers and instruction set or some of the fundamental concept of microprocessor, let me ask you this. How does your smartphone respond to your touch instantly? Can you tell me? And also, how does a car parking sensors know you are too close to the wall? And can you tell me how does your microwave stops exactly at the time? The answer is a microprocessor or a microcontroller is silently working behind the scene. In this course, we will learn how this small but a mighty chip control the massive parts of our modern life. Let's start from here and we will have an overview and the remaining course content we will see in this session. Here's what this course will cover. We have a prerequisite, we have objectives, we have the outcomes and the syllabus and chapters, and I break down the assessment technology and what are the assessment activities are there, timeline and industry orientation, especially how the semiconductors are plays a huge roles in shaping in our future. So this course will give you the fundamental of hardware design or an embedded system field. When you want to become a firmware engineer, this will give you a strong foundation. Prerequisite. You no need to need an expert to be a startup in this microprocessor microcontroller, but a basic understanding of an electronics, digital logic circuits, a linear integrated circuits, logical system, binary system, and some basic programming logic will be very helpful to understand this course. So these are the prerequisites for your microprocessor and microcontroller. And this microprocessor and microcontroller, here we are mentioning some of the keywords like touch, feel, and you can saw, and you can eat, and you can taste, which resembles direct meaning to when you have a touch screen in the real time world, you can interact with the touch screens. When you want to feel that, you can have some temperature sensors or any type of sensors you are using. When you want to have a smart cooking system like what you had for in your kitchen, those are things you can able to take it for eatables. And when you have a beverage machines adjusting sweetness that makes you to make a taste of what the food you are having. And you might see a lot of optical sensors in an automation project around you. So you can able to touch, you can able to feel, and you can able to saw, eat, and taste for this entire particular technological based course, microprocessor and microcontroller. The main course objective for this microprocessor and microcontroller, it infer the fundamental components of, or I can say, a understanding of fundamental components of an 8085 microprocessor and 8051 microcontroller, and we are going to discuss how to write the assembly language programming with examples and what are the peripheral interfacing ICs that makes our microprocessor to become a more strong and having an additional features, and the coding and the debugging system of your 8085 and 8051, and the real time examples which we are having a case study, and the fundamental architecture. These are all the things we are going to discuss in this particular course. Course outcome. You will walk away from the course with the ability to design a code and debug a system Of course, once you successfully completed this course, you might have an idea to interpret the architecture of controller and the processor. And you might have an idea to have an observation of what are the things we are happening behind the programming, inside the programming, or in a case of 8051 assembly language program or 8085 microprocessor assembly level program. And we will discuss a commonly used peripheral ICs with the programming. And you will take away the outline of a simple programming skill in a microcontroller and its application. And of course, the today entire world in embedded industry, what are the things we are having, what are the keywords we are having in industry, those are all the things you can take away from this course. So these are the 5 important course outcomes of the microprocessor and microcontroller. And you understand these are the outcomes and these are the objective. So for reaching these are the outcome, you should have a proper of a syllabus structure and chapters. So here the MPMC, the microprocessor and microcontroller, have divided into a syllabus smartly to help you grow from a fundamental concept to complex applications. Each unit building upon the last technology that reaching you on a higher level. So let me take the unit 1. It will discuss about architecture and memory interfacing of 8085. And unit 2, we are going to discuss how to program in 8085. Unit 3, the peripheral interfacing concept. Unit 4, the microcontroller 8051. And Unit 5, the microcontroller application. So these are the syllabus structure. We are going to start by using the microprocessor microcontroller. And the textbook, so this particularly we are using a 2 textbook. One is from Krishna Kant, Microprocessor Microcontroller, Prentice Hall publication. And another one is Muhammad Ali Muzadi and the 8051 microcontroller and the embedded system, Pearson Education, 2003 publication here. And we had 3 reference books. And of course, you might have a lot of and YouTube and NPTEL videos are there and some of the online platform that will help you to understand the programming concept of the microprocessor. You can also refer some of the digital references which I mentioned in this slide. The assessment of the course includes the assignments, quiz, some hands-on programming examples, and interfacing based mini projects, and some of the MCQ I'm going to ask. And these are the method I can able to access this particular course. A simple roadmap that will make you to understand what is the timeline goal of this course. So the timeline goal of the course will clearly give and guide you what are the weekly learning is going to start with 805, 8085 microprocessor, then 8051 microcontroller, interfacing and advanced microcontrollers. So this is a flow that make you to understand where the course is going to start and where I can going to make an end. And once you start this course, you start learning, you must do to understand the 4 important, very important factors. One is a pin diagram and architecture. And the second one is you have to understand the instructional set and what are the program codings are there that you should understand. And I'm going to use some of the simulators and some of the tools that may going to help you to understand in your real-time oriented applications. And you must use some of the laptop and you must use some learning online tools and all. The heart of the computer is a semiconductor technology. So the heart, so we can say the microcontroller is going to manufactured by the lot of semiconductor industries only. Think about the Intel, ARM processor, Texas Instruments. So these people are powering and everything from your smartphones to your rice cooker. So they are providing a lot of an integrated circuit ICs that also combines the microprocessor and microcontroller that facilitate a lot of application oriented to the industry. And what the way we can start. So this is about the introduction about the course and where I can start and what the way we can start if you are asking means. We can start from the beginning, the history revolution that is in from 8085 microprocessor in the year of 70s or 1970s to the ARM Cortex in the today IoT technology. So there are a lot of evolution is going to make here. So those evaluation drives the innovation. So I can start from an 8085 history to the till the ARM Cortex in this particular course. So this is the way we are going to start for your microprocessor microcontroller class, and this is the way we can able to proceed for the forthcoming sessions. And let's here from start we can start out our unit 1 from the tomorrow major processing. And of course some of the kitchen appliances are there, induction cooktops. We are using the 8051 microprocessor microcontroller, that is 8051 based MCUs, that also we are going to play it in a today bolt. So these are the real-time application of our microprocessor and microcontroller. And this is about the course introduction. Here I am going to wrap up our introduction to the microprocessor and microcontroller. In the coming classes, you will not only understand how system works, but will also build a logic, write a real-time programming, and think like a hardware problem solver. And you are going to understand more and more about microprocessor and microcontroller. Don't forget to explore and experiment and engage, because the best way to learn your microprocessor or microcontroller is to control your own curiosity. With this view, I wind up the today's session. We will discuss the remaining part in the next session. Thank you, everyone.